Hello, this is Dr. Mode and welcome to chemistry class today. Today we're going to continue talking about acids and bases and finish the section on pH. Our scripture from today comes from Psalm chapter 92 verses 1 through 4. It is good to give thanks to the Lord and to sing praises to your name, O Most High, to declare your loving kindness in the morning and your faithfulness every night, on an instrument of 10 strings, on the lute and on the harp, with harmonious sound. For you, Lord, have made me glad through your work. I will triumph in the works of your hands. So the big idea in chapter 18 is acids and bases can be defined in terms of hydrogen ions and hydroxide ions, or in terms of electron pairs. As you can see, we're finishing up section 3 today, called hydrogen ions and pH. The essential questions from this section are, what are pH and pOH? How are pH and pOH related to the ion product constant for water? How are the pH and pOH of aqueous solutions calculated? A typical ammonia cleaner has a hydroxide ion concentration of 4.0 times 10 to the negative 3 molar. Calculate the pOH and pH of the cleaner. So again, what we've been given here is the hydroxide ion concentration. So what we're going to do is we're going to use the equation that pOH is the minus log of the hydroxide ion concentration, and we're going to plug that number in that we were given. And our calculator is going to tell us that this is a pOH of 2.40. Now we also need the pH, and what we're going to use here is the fact that pH plus pOH equals 14. So if we solve this for pH, we got 14 minus the pOH. So we plug in the 2.4, so 14 minus 2.4 gives us a pH of 11.60. What are the hydrogen ion concentration and the hydroxide ion concentration in a healthy person's blood that has a pH of 7.40? So again, what we've been given is the pH of 7.40. So our equation for pH equals the negative log of the hydrogen ion concentration, and that's what we want, the hydrogen ion concentration. But it's tied up in this log. So what we have to do is we have to use the anti-log, which is taking 10 to the negative pH, and that would give us the hydrogen ion concentration. So if we take 10 to the negative 7.40, that's going to give us the hydrogen ion concentration of 4.0 times 10 to the negative 8 molar. Okay, so again, try this out on your calculator. Make sure that you're able to reproduce this number and get this result. So we also need the hydroxide ion concentration, and what we can do is we can use the equation that we saw earlier, how the product of the hydroxide ion concentration and the H plus ion concentration equals 1.0 times 10 to the negative 14th. So if we rearrange this, solve for the OH minus concentration, we're going to take that Kw divided by the H plus ion concentration that we just calculated, and that's going to give us the hydroxide ion concentration of 2.5 times 10 to the negative 7 molar. Again, this result is a little tricky to get from your calculator. Make sure that you test this out and you're able to get this number.